Hello, sir.
Good evening, sir.
Very good evening.
Good evening, sir. Oh, with it.
Yeah, just give me a moment, dear children.
Yes, sir.
So, dear children, if my screen is visible, please give me a thumbs up. Okay, that's great. Uh, so I'm just trying to recollect where did we stop last time. So we had started with rational numbers last time, I believe. Positive,
Yes, sir.
negative, we dealt with it. So I told you, like, basic rules is like whenever you see a negative sign in the denominator,
Yes,
you have
sir. You
to bring
told.
that negative sign to the numerator. Okay, so this is the basic rule which I've told you whenever you see a fraction. Okay, so thumb rule, always bring the negative sign to the numerator. Okay, so whenever you see, well, if there is only negative sign in the denominator, then you directly bring it to the numerator. If it is already in the numerator, then कुछ करने की जरूरत नहीं है, because we need the negative sign to be always in the numerator. Thumb rule. Okay. When there are two negative signs in the numerator as well as denominator, you can simply cancel them and then reduce the fraction. Okay. Now, the representation of the rational numbers in the number line. This also we have discussed. To comparison of rational numbers, how do we compare? We Sorry, in the background somebody is speaking. Okay, I'll just okay. ठीक है. So what I was saying, yeah, whenever we wish to compare two rational numbers, what you're supposed to do is you're supposed to make the denominator common. So once you make the denominator common, you can easily compare which rational number is greater, which one is lesser. It's easier to compare. Okay. And a shortcut method we had discussed, you simply cross multiply them and see whether left hand side is greater or right hand side is greater. For this, the only condition you have to follow, which I've already told you, is basically, sorry, is basically make sure the negative sign is always in the numerator, not or never in the denominator. Okay. And yeah. And operations on rational numbers are basically addition operation is just like normal fraction additions. So there is a plus sign in between. If there is a negative sign, you can combine and plus and minus becomes minus. 4 minus 14 gives you minus 10. Sorry. And if the denominators are same, then there is no problem. If the denominators are different, what you have to do is basically take LCM, make sure there is a common denominator for both the numbers, and then you solve the numerator, you get your fraction. Okay. And in the end, if it is possible for you to reduce the fraction, you always try to reduce. In this case, it is not possible to reduce the fraction, but in this case, it is possible to reduce the fraction. 18 and 15, they go by the table of 3. Now, regarding subtraction, again, it's the same story, just like how, normal fraction subtraction, you just have to make sure that denominators are same and then combine the signs and then simply solve. Regarding multiplication, you do not have to think about them having common denominator or not. You can directly multiply numerator with numerator and denominator with denominator. You can directly divide this denominator with the other numerator, this numerator with the other denominator. Any numerator can be divided with any denominator. There is no compulsion that one, like if there are two fractions, the first fraction's numerator can be divided only with the first fraction's denominator. ऐसा कोई compulsion नहीं है. There is no compulsion as such. For example, in this case, in the example number 3, as you can see, here I have 2 and here I have 4. I can cancel these 2 and 4 with each other. Basically, 2 ones are 2, it becomes, and 2 fours are, sorry, 2 twos are 4, it becomes. That's what it has become over here. This 2 over here became 1 on the other side, and 4 became 2. Basically, they reduced the fraction. So you can reduce them. And obviously, as you know, if when you write the final answer, minus multiplies with minus to give you plus. So the numerator becomes plus 3 and the denominator becomes plus 10 in this case, in this particular example. And any fraction multiplied by 0 gives you 0 only. Okay, always remember that. And any fraction multiplied by 1 gives you the same fraction. For example, 5 by 6 multiplied by 1 gives you 5 by 6. So I suppose multiplication is clear so far. Any doubt in multiplication?
No, sir.
No, sir.
Okay, that's great.
No,
No,
sir.
sir.
Okay. So speaking about division, speaking about division. So whenever you see division, what you have to do is see basically there are two fractions. One is fraction number 1 and the other one is fraction number 2, right? So always there is a very simple technique on how to deal with multiplication. I'm sure you might be aware of it. So whatever is your second fraction, you can simply swap them, the numerator and
Reciprocal.
denominator. Yes, take a reciprocal of them. So 2 by 7 becomes 7 by 2. When you do this reciprocal thing, this division symbol becomes a multiplication.
Multiplication.
Yeah. So once you have multiplication in hand, you know how to deal with it. We have already done multiplication. Whenever you see division, you simply take reciprocal of the second fraction to make it multiplication and then proceed further as a multiplication problem itself. Hmm. Yeah. Now, irrational numbers.
Sir,
Yeah. Kevin, tell me, what's your doubt?
sir, it's Kavan, sir. I had a small doubt. Sir,
Yep.
in this question, like 21 by 24 or
Yep.
7 by 8,
Hmm.
can't we multiply it by 8 so that we can get like uh 56?
Yeah. See, basic thumb rule. So what happened over here? You divided 21 by 3 and you divided 24 by 3. So you did a division in the numerator as well as in the denominator. If division in the numerator and denominator are allowed to get 7 and 8, similarly, multiplication in the numerator and denominator is also allowed. You can multiply numerator by any number as you wish. The only condition is you will have to do the same thing in the denominator also. You cannot, isolate numerator from denominator. They are a pair. Whatever you do in the numerator, you will have to do the same in the denominator also. For example, in this case, if you multiply by 8, but you'll have to multiply 8 on both sides. So 7 multiplied 8 becomes 56 and 8 multiplied by 8 becomes 64. This is what you were asking, right, Kavin?
Yes, sir.
Yep. I'll proceed now.
No.
Speaking about Hamza, would you like to say something? You're unmuted. I'll mute you for now. If you have any doubt, you can raise your hand and you can ask me. Okay, not a problem. Yep. So whenever see what happens, I understand sometimes by mistake your mics get unmuted. Uh, so how will I know whether you are actually trying to ask a doubt या फिर by mistake unmute हुआ है क्या? It happens. So for the smoother functioning, I'll request you to, before unmuting yourself to ask any doubt, I'll request you to raise your hand first, and then I'll tell you, okay, fine, ask your doubt, and then you ask your doubt, like rather than directly unmuting yourself. तभी क्या, आई बी वेरी क्लियर, ओके फाइन, ये बच्चा डाउट पूछने वाला है. अदरवाइज मैं हमेशा कंफ्यूज हो जाता हूँ कि व्हाई डिड दिस बॉय और गर्ल अनम्यूट themselves? Are they going to ask the doubt, or is it by mistake? Okay. Yes, Naitik, you have raised your hand. Tell me what's your doubt.
Sir, in when I take 21 by 24 and multiply the numerator and denominator by a number, same number, like 8 by 8 or 7 by 7, then I always get 7 by 8. So, this is because 7 by 8 is the simplest form, right?
Yes.
Okay, sir.
So good doubt, Naitik. So for everyone's attention, I'm telling you, my dear children, irrespective of whatever fraction, well, for example, in this case, -21 by -24, आपको जो करना है करो इसमें, like multiply by some number or divide by some number, whatever you want to do, you do it. So in the end, when you cancel all the extra numbers and try to bring the simplest form will always remain same. It will never change. Okay? Because whatever number you have multiplied in the numerator, you're doing the same in the denominator. Basically, they are balanced. 8 and 8 आपस में cancel हो सकता है. They are balanced. If you're dividing by 2 in the numerator, you're doing the same in the denominator also. They are also balanced. Since whatever operation you're doing, since they are balanced operation, it doesn't matter whichever number you use. In the end, if you when you find the simplest form, you will always get the same answer. That is, in this case, it will always be 7 by 8.
Okay, sir.
Yeah. Okay, going forward, speaking about irrational numbers, we know that any irrational numbers can be expressed in the form of recurring decimal fractions. Sorry. Now let's discuss what is recurring decimal fraction. For example, if you have 1 upon 2 as a fraction, when you try to convert it into a decimal number, it is basically 0.5. 0.5, उसके आगे कुछ है क्या? नहीं है. Nothing is there beyond it. It is, purely 0000 after it. So nothing is there beyond it. Hence we call it as terminating decimal form. Terminates means khatam hota hai. So it ends over here. Therefore, we call it as terminating decimal form. Another example is 3 by 4. So when you divide 3 upon 4, the answer you get in the decimal form is 1.25, which is again terminated. उसके आगे कुछ भी नहीं है. Therefore, I call it as a terminating decimal form. But when you divide 1 upon 3, the answer you get is 0.333333. This 3 never stops. So when you try to divide also, there is always 3 coming all the time. So what is happening? This 3 is recurring. It is repeating. Repeating का दूसरा word है recurring. Okay. So whenever a single number or a set of numbers are repeating, we call them as recurring because it doesn't have any end. It is not going to end. It is going to continue. Therefore, I call it as non-terminating. Okay. Uh, okay. Three persons have asked doubts. Yes, Viva.
Sir, how is 3 upon 4 1.25?
Oh, sorry. This is a mistake. Yeah, thank you. Thank you. It is 0.75. This should have been 5 upon 4. It's a printing error.
Okay.
अच्छा.
Yeah.
Thank you.
And ऋषिक, सेम डाउट था कि अच्छा ठीक है, सबका हाथ नीचे गया. वेरी गुड. Just give me a minute, my dear children.
Sir, I'm sorry, I by mistake drew on the board.
Yeah, no worries, no worries. Thank you for accepting and acknowledging that. Not a problem. Okay. So, Prithvi, if your query is over, you can put your hands down, by the way. Yeah. Yeah. Conversely, any number which can be expressed in the form of recurring decimal. Now we know what is a recurring decimal. Okay, is called as a rational number. Now, find the square root of two by division method. Let's try to find. So this is 2. We are going to try to find this square root of 2. So basically, I'm not going to explain the whole division, okay, because in this chapter we are not going to focus on that. We have already dealt with this in the square root chapter also. Okay, so I'm not going to repeat everything. So I'm just proceeding further. For those who don't know how to find the square root of 2 by division method, please go through the recording. Our class is recording, which I've where I've taught you how to find square root using table, the division method. Okay, you can just check the recording. Initial first year second class में सिखाया मैंने आपको. Thus, ultimately, when we found the answer was like 1.4142. Thus, root 2 is a non-recurring and non-terminating decimal fraction. Similarly, root 3, root 5, root 7 are non-recurring and non-terminating. So, non-recurring, matlab, this is not recurring. So, as a 4-1 आया, then 4-2 आया. So, it's not repeating. अगर 4-1, 4-1, 4-1, 4-1 repeat होता, या फिर after 4, if 1-1-1-1-1-1, they were repeating. So then we would have called it as recurring. वो भी repetition should be unlimited repetition. ऐसा नहीं कि 2 बार repeat हुआ तो we call it as recurring. No, 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 no. It should be an unlimited repetition. Non-stop repetition. Hence we call it as non-terminating also. So since this is not repeating non-stop, we'll say it is non-recurring. Now it is a non-recurring fraction. Okay, first of all. But is it ending over here? No, because as you can see, when you take a difference of this number also, you will get some difference. The remainder is not zero. There is some number coming again. So जब तुमने इन दोनों को subtract किया, you got some number, you solved it. Now when you see forward, there is some other number coming. So again, when you continue further, some or the other time, some or the other numbers are coming. So 1.4142 after 42, is it ending? No, it is not ending. Since it is not ending, end means terminate hona. If it was ending, I would have said that it was a terminating decimal fraction. Since it is not ending, I will call it as non-terminating decimal fraction. Okay? They are non-terminating. They will not end. But उनमें repetition है क्या? No, they don't have repetition. So they are called as non-recurring also. Similarly, in root 3 also, when you try to find root 3, when you try to find root 5, when you try to find root 7, all these numbers, they don't have recurring numbers. Hence, we say it is not recurring. But at the same time, it is also not stopping. It is continuing further. So we call it as non-terminating also. All these numbers are called as irrational numbers. Okay. So rational numbers means क्या है? एक certain stop है उसके पास. Irrational numbers means stop नहीं है उसके पास. वो चलता ही रहता है. Pi is also an irrational number. Its approximate value is 22 upon 7. Now, for those who don't know what is pi is generally, for now, you just understand this symbol. The symbol's name is pi. I'll just write the spelling of it for you to understand. Sorry, PIE. PIE is the spelling of this particular symbol. How does it look? It looks like this. You draw a straight, not exactly straight, or thoda sa slant line. एकदम थोड़ा सा, नॉट इतना भी स्लांट नहीं, एकदम थोड़ा सा स्लांट लाइन, एक और थोड़ा सा स्लांट लाइन एंड एक स्लांट टोपी. सो दिस सिंबल इज कॉल्ड एज पाई. ओके, कुछ ज्यादा ही स्लांट हो गया, इतना स्लांट भी करने का जरूरत नहीं था. इट वाज समवॉट लाइक दिस. या सो दिस सिंबल इज कॉल्ड एज पाई. PIE, pi. Now what is pi? Pi is a number which we use to calculate the area, calculate anything related to circle. Circle से related कुछ भी चीज calculate करने के लिए we use pi. आपके सिलेबस में पाई आपने देखा है क्या? डू यू नो व्हाट इज पाई?
Yes, sir.
Yes, sir.
Okay,
Yes, sir. We know.
fair enough. Since you're aware, I don't have to worry. I was wondering whether it is covered in your syllabus or not. Okay, fine. So pi's value is basically 22 by 7. When you divide 22 by 7, you will get 3.14 and something. उसके बाद चलता ही रहता है. So that is, since वो चलता ही रहता है, it is not terminating, hence we call it as irrational numbers. Okay. So, sorry. I'll just take a quick recap. Uh, किधर गया? हाँ. Irrational numbers means those numbers which are non-recurring and non-terminal, not terminating decimals. They are called as irrational numbers. Okay. Now, now terminating, non-terminating के बीच का difference, you know, terminate means खत्म होता है, non-terminating means खत्म नहीं होता है. Okay. And non-terminating में if the numbers are repeating, we call it as they are recurring. Okay. हाँ, by the way, rational numbers, just a minute. Okay. Uh, huh. So I'll just complete the explanation and then I'll take the doubts. Okay. So that's why I know you guys have raised the hands. You keep your hands raised. जब तक आपका डाउट है तब तक हैंड्स रेज्ड ही रखो. इन दी एंड अगर आपको लग रहा है इन दी बाय द एंड ऑफ द एक्सप्लेनेशन अगर आपका डाउट क्लियर हो गया देन यू पुट योर हैंड्स डाउन, अदरवाइज यू कैन पुट योर हैंड्स अप ओनली. So so how to show this root 2 on number line? Okay. So root 2, how to show? For example, this is your number line. Do you know what is Pythagoras theorem?
Yes, sir.
Yes,
Sir.
sir.
Yes,
Okay,
sir. A
wonderful.
square plus B square is equal to C square.
C
Yes.
square.
So let me assume, so this is a number line. Let me assume this point, its origin. Origin means apna, sorry, this point is origin. So if this is origin, which means this is number 0. This is number 0. So left side ki taraf, how much ever we go further, it becomes like, ignore this. This is -1. And on towards the right hand side, when we go, like, let me say this distance, this is 1. That means this distance which we have covered is basically 1. So far, so clear? From 0 to 1, whatever distance we have covered is 1. Am I clear?
Yes, sir.
Great. So let me draw, if this is 1, let me say I'm drawing one more distance from this point to this point. This will also be 1. Well, I'm drawing 1. Okay. So I'm drawing a perpendicular line vertically up at a distance of 1. So मैंने scale लिया, 1 का distance मैंने mark किया. इतना clear है? Now, what I've created, now when I join these 2 points, so what I've created is basically a right angle triangle where one side is, let me call this side as A, is equal to 1. Another side, let me call it as B, that is also equal to 1. So according to Pythagoras theorem, we can find the length of the hypotenuse, which we call it as C. So when we try to find the length of the hypotenuse, you know the formula, it's basically A square plus B square is equal to C square. A is 1, 1 square is 1. B is 1, 1 square is again 1 only. That is equal to C square, which will give me C square is equal to 2. That will give me C is equal to root of 2. So the length of this particular side hypotenuse is how much? It will be root of 2. Now the question is how to express root 2 in the number line. From origin, I take distance 1 horizontally, then I take distance 1 vertically, then I join the origin with this particular point P. Whatever distance is covered by this hypotenuse, that distance will be called as root of 2. So this is how we can express root 2 in the number line. So, and logically speaking, like I've already, like these points, they have already mentioned over here, how to express origin से लेने का distance वगैरह वगैरह. Anyway, uh, and logically speaking, root 2's value. So we have already discussed the value of root 2. It is basically when we try to find the value of root 2 by division method, we found that the root 2's value was 1.4142 and so on. It was proceeding further. Since it was uh, okay, it was proceeding further and it is called as irrational number. Now the question is, this is an irrational number. Now if I'm asking you, ठीक है, Pythagoras से you made this root 2 and all. Now simple logic में अगर बोले how to express, अभी तो see the number line is this horizontal stuff, right? Now I know that this distance is root 2. Now the question is how to express this root 2 in horizontal line. The answer is very simple. You take a compass, you put your point over here, and यहाँ से एक arc बनाओ. When you make the arc, जहाँ पर भी intersect होता है, this obviously this if this distance is root 2, then this distance will also be how much? It will be root 2. So this is how we can mark root 2 in number line geometrically. Now logically speaking, root 2 is 1.414, which is definitely greater than 1 and less than 2. So in the number line between 1 and 2, you can find root 2. So I'm just giving you a logical approach how to find root 2 in the number line. It will be between 1 and 2, somewhere between 1 and 2. Exactly speaking, 1.4142. Okay. Now, to highlight this point, if root 2 can be found on the number line, similarly, root 3 also can be found on the number line. My geometrical method, though, I've already explained. I'm not going to repeat that. Logically speaking,
Yes.
like root 3 is 1.73. So again, this root 3 is somewhere between 1 and 2. So that means root 3 is somewhere over here. Let me say it's over here. Similarly, root 4. Root 4, what is root 4? It's 2 only. It's already there in the number line. What is root 5? It is 2 point something. Let me say, I'm just randomly assuming it is 2.2. If it is 2.2 or 2.3, then that is also there in the number line. Similarly, root 6 will also be there in the number line. Root 7 will also be there in the number line. Root 8 will also be there in the number line. Root 9 will also be there in the number line. So all the roots, which are technically speaking irrational numbers, will be there in the number line. So that is this point. All irrational numbers can be expressed on the number line. All the rational and irrational numbers together are known as real numbers. Thus, all the real numbers are represented on the number line. So these 3 points you must remember. So when just to summarize, simple language में अगर मैं बोलूं, what is rational and what is irrational? Simple language में rational numbers can be expressed in fraction. Irrational numbers cannot be expressed in fraction. In simple language, that is the answer. Very simple language. So if I'm just simply asking you 0.3333333 recurring. Now, is this number a rational number or irrational number? Type your answer in the chat box. Okay, many students gave me the correct answer. I'm really glad. Okay, so let me just explain the answer. Before explaining the answer, I'll just give you the logic. What is the logic behind identifying rational and irrational? Rational can be expressed in fraction, irrational cannot be expressed in fraction. Okay. Now, दूसरा पॉइंट क्या है? रैशनल के अंदर भी रेकरिंग हो सकता है, इरेशनल के अंदर भी रेकरिंग हो सकता है. रेकरिंग इज पॉसिबल फॉर बोथ ऑफ देम. Rational can also be non-terminating. Irrational can also be non-terminating. Rational can be terminating. Irrational can also be terminating. Like ठीक है, terminating नहीं लिखते हैं. उसके बारे में मैं कमेंट नहीं करता हूँ क्योंकि टर्मिनेटिंग इरेशनल में जनरली आता नहीं है, नॉन टर्मिनेटिंग ये होता है. ठीक है. सो दीज पॉइंट्स यू मस्ट रिमेंबर. नाउ This is 0.3333 recurring. Just because it is recurring मैं directly बोल नहीं सकता कि वो irrational है, क्योंकि rational के अंदर भी recurring numbers हो सकते हैं. It is possible. But the real question is, can this 0.33 be expressed as a fraction? Yes, it can be expressed as 1 upon 3. Since it can be expressed in terms of 1 upon 3, 0.33 is a rational number. Your answer is rational. Why 0.33 is rational? Because it can also be expressed in 1 by 3. So 0.33 is also a rational number, 1 by 3 is also a rational number. Whereas if I'm telling you 1.4142, whatever is the number, is that a rational number? No, because that is the answer to the root 2, right? It cannot be expressed in a fraction. It can be expressed as a some other thing. Well, since it cannot be expressed as fraction, I will call it as irrational number, or 1.732, that is also irrational number, and so and so. Okay. Yes. Now one by one I'll handle the doubts. Naitik, tell me.
Sir, I have done many 4 to 5 doubts. In irrational, you take the recurring, but how it can be recurring?
Okay, I'll just show you one thing. In the first line itself, okay, in the first line itself, I told you, we know that any rational numbers, sorry, my bad. Yeah, any rational numbers can be expressed in the form of recurring decimal also. So, which means rational number can also be a recurring decimal. Hence, 1 by 3 or
Sir, but
0.33
you
is a
take
recurring.
in irrational.
Sorry.
In the irrational, you wrote that irrational numbers are recurring. That's
Yeah,
in that you take.
irrational numbers are also recurring. For example, this number 1.41. Oh, recurring. Oh, my bad, my bad, my bad. Recurring, I told, right? Mm,
So that is
mm,
wrong.
irrational numbers. I'm just trying. हाँ, there is ऐसा तो कोई एग्जाम्पल तो मेरे दिमाग में आ नहीं रहा है, which is recurring
Sir,
and
the thing that
irrational.
makes them irrational is non-recurring and non-terminating. Both
Correct.
conditions should be satisfied.
Hmm. Correct, 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 correct. My bad, my bad. हायर क्लासेस में शायद
And
एग्जांपल्स
sir,
आएगा, बट लोअर क्लासेस में नहीं है. करेक्ट है. हाँ, चल
I
मी.
have one more doubt. Uh, in the when drawing root 2 on number line, so when drawing that arc, you took O as center and OP as the radius, right?
करेक्ट, करेक्ट, करेक्ट.
And how do you make root 3? Because using Pythagoras means I'm not able to get the idea.
ओके, सो यूजिंग पाइथागोरस इफ यू विश टू डू, पहले तो हमें ये निकालना पड़ेगा. नाउ यू नो हाउ मच इज रूट टू. नाउ व्हाट यू विल हैव टू डू, हाउ विल यू फाइंड रूट थ्री? सिंपल फंडा. सो 1 + 2 gives you 3, right? So इसका स्क्वायर रूट, 1 का स्क्वायर रूट इज 1 ओनली, 2 का स्क्वायर रूट इज रूट 2, 3 का square root gives you root 3. So your first side should be 1. The second side should be root 2. That's when you get the answer as root 3. Simple funda. Okay. Now that means
Okay,
since you
sir.
have हाँ root 2 यहाँ पर है. Now the next target is आपके पास इतना root 2 का distance है. You have this root 2's distance. Now what do you do? From here you draw 1, and whatever you join this point and this point. Now root 2 and 1 combine, okay, you it will give you root 3. And then you take a compass and join them to find root 3 over here. Understood?
Yes, sir. And in you said pi is actually circumference upon diameter, no, of circle.
Pi uh, 22/7 का रेशियो आया है. या circumference upon diameter, correct.
And sir, one more doubt, last doubt. In when you were teaching square root, how to find the square root of a irrational means like root 2. it is a irrational number. So
Mm-hmm.
you said that suppose it is asked in the question, find the square root of 2 up to 2 decimal places, then we have
Mm-hmm.
to take two pairs of zeros. So here they have found out to 4 decimal places, 4 1 4 2. So they
Mm-hmm.
should take 4 pairs of zeros, right? So 8 zeros, but they have taken only 2 pairs, so they should get only 1.41. But how did they get 4 2?
Okay. I will suggest you to once go through the recording of square root wala chapter so that your doubt is cleared in that aspect. Okay. एक बार go through
Sir,
कर लो.
I know this one, but
I'm listening.
sir,
Okay.
means I know the topic. I had attended the class also.
Mm-hmm.
But you had told specifically that when we have to find the root of a number which is not a perfect square up to a certain amount of decimal places, we
Mm-hmm.
have to group. So we have to add zeros in front of that. Suppose I want
Mm-hmm.
till two decimal places, then I will
Mm-hmm.
add two pairs of zeros. So four zeros of that
I
number, and then find the square root.
no. But that logic I did not give for the division method. I did not give that logic for the division method.
Sir, but that is the logic. Means
No, for
it's
division
taught in
method
our
I
school
might have.
also.
Uh, I don't think I might have given that logic for the division method. But this is correct only. I don't see any mistake over here.
Sir, the mistake is after taking 1 point, two zeros came down to make it 100. Then
Mm-hmm.
after minus 96, 4, then two zeros came down to make it 400.
Mm-hmm.
Then 119, 119, then two zeros came down, but two zeros
अच्छा
should
अच्छा
be
that you
added.
are saying. Okay, 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 okay. हाँ, okay, okay.
Yes.
वैसा. हाँ. You're correct. You're correct.
Uh,
You're absolutely correct. Hello?
Yes, sir.
Yeah. There should be
Yes,
one,
sir.
two, three,
Understood.
four pairs of zeros over here. अच्छा अच्छा that you were saying. Okay.
Yes, sir.
ठीक है.
Okay, sir. Thank you.
Hmm. Rishik, tell me what's your query.
Now,
अरे
sir,
just a minute,
what
just a minute.
exactly?
Rishik and Rishan. I'm sorry, I just realized we just have 1 minute for this meeting to end. Let's do one thing. Let's exit and join again, dear children.